Hi everyone! Today we'll be looking at coterminal angles. Here's today's FLT. Given an angle, I will be able to find its coterminal angle. So today we'll be taking a look at coterminal angles. So in general, we've been looking at angles drawn on a coordinate plane. So here I have the x-axis and the y-axis. Our angles start at the positive x-axis. So the starting point of the angle is called the initial side. And then we're given an angle. So we're given an angle theta and the side where the angle ends up. So this depends on the angle we're looking at, but this is called our terminal side. And a good way to remember this is to know that terminal can also mean the end. So we start at the initial side and then move our angle and end up at the terminal side. And so to be coterminal means to end up at the same spot. And we'll take a look at what exactly that looks like. So to be coterminal means to end up on the same terminal side. All right, so I'm not the best artist here, but pretend you're looking into like a classroom or a coffee shop or whatever, just a generic room, and think of it as looking at it from the top, so a bird's eye view. I do not know how to draw a stick figure from bird's eye view, so yeah, bear with this. But, so in this case, in the first image, my person is facing the door. Think of the door as being 0 degrees. And then what happens if I turn halfway around? Now I'm facing the windows. And since I did half a circle, this would be labeled as 180 degrees. But what if I started off by looking at the door, but then turning around to look at the front? I did a 90-degree turn, so I think of this as a 90-degree angle. And lastly, what if I face the other side of the room, so the back side? This would be identified as 270 degrees. So basically what I'm doing here is, compared to the usual coordinate plane, I'm just transferring it to a room so that hopefully it's a little bit easier to visualize. And so we'll use this illustration to illustrate what coterminal angles would look like. So what does it mean to be coterminal? So let's say I start off by facing the door and I turn 90 degrees to face the front. Let's say I go the other way, but I still end up facing the front. As long as I end up facing the front, that means I'm coterminal no matter how many times I turn around. And then here's a more mathematical illustration. So notice here, if I dragged point A, the angles are coterminal. And even if I do a few loops, as long as I end up on the same terminal side, the two angles are considered coterminal. And this is true even if I go in the negative, so the clockwise direction. Notice how as long as I end up on the same terminal side, the two angles are coterminal to each other. So let's look at an example here. Let's say I go 90 degrees. So I start from my initial side and move 90 degrees. Let's say I do a full circle plus an extra 90 degrees. So in this case, I did a full circle, so 360 degrees, plus the additional 90 degrees. 360 plus 90 is 450, so 450 degrees. Notice how we end up on the same terminal side. So we can say that 90 degrees and 450 degrees are coterminal because we're ending up at the same terminal side. So even though I did an extra loop for the 450 degrees angle, these angles are still coterminal. So in general, when you're asked to find a coterminal angle of a given angle, you want to give an angle that's between 0 and 360 degrees because that's what we're used to seeing. Like we're used to seeing angles that are between 0 degrees and 360 degrees. And again, theta just represents an angle. So basically, if we think about it in a number line format, we want an angle that's between 0 degrees and 360 degrees. So we're going to be given angles that are either less than 0 degrees or greater than 360 degrees, and we have to find their coterminal angles by either adding full circles or taking away full circles. So let's say the given angle is less than 0 degrees. So let's say the angle is a negative angle. In that case, we would add a full circle. So we would add 360 degrees to find a coterminal angle. And then let's say we have an angle that is greater than 360 degrees. In that case, we would take away a full circle. So we would subtract 360 degrees and find its coterminal angle. So for example, we looked at 450 degrees, which is larger than 360 degrees. To find its coterminal angle, we subtract a full circle. So we subtract 360 degrees and get 90 degrees. And so that's how we know that 90 degrees and 450 degrees are coterminal angles. So for our first example, we are going to find a coterminal angle theta of 520 degrees. And we want to make sure that the coterminal angle is between 0 degrees and 360 degrees. So I noticed that 520 degrees, which is the given angle, this is larger than 360 degrees. So it would fall in this area. And then so how can we find a coterminal angle? Well, we simply start with 520 degrees and subtract a full circle from it. So we subtract 360 degrees from it, and 520 degrees minus 360 degrees would be 160 degrees. So I know that 160 degrees is a coterminal angle of 520 degrees. And let's see how this draws out on an actual coordinate plane. So 160 degrees, the coterminal angle, is somewhere here in quadrant 2. So this would be 160 degrees, and this is our terminal side. 520 degrees is a full circle plus a little bit extra. It's a full circle and an extra 160 degrees. And notice how we still end up on the same terminal side right here. So that's how we know that the two angles are coterminal. All right, let's look at example 2. We're going to find a coterminal angle of 770 degrees. Again, we want our angle theta to be between 0 and 360 degrees. Notice how 770 degrees is a lot larger than 360 degrees. So what we're going to do is start off with 770 degrees, but take away a full circle. So taking away a full 360 degrees. And then 770 minus 360 is 410 degrees. Notice how this is still larger than 360 degrees. So what we can do is take away another full circle. 410 minus 360 equals 50, so 50 degrees. So 50 degrees is a coterminal angle of 770 degrees. So notice how for the 770 degrees, we have to do a few extra loops, but we would still end up on the same terminal side. So although 50 degrees and 770 degrees are different angles, they still end up on the same terminal side right here. And actually, in this case, we can say that 50 degrees and also that 410 degrees in between and 770 degrees are all coterminal angles. So as long as the angle ends up on the same terminal side, so as long as they end up in the same spot, the angles are coterminal. All right, for example 3, we're going to find a coterminal angle of negative 100 degrees. Notice how this is smaller than 0 degrees, so somewhere over here. So in this case, what we're going to do is add 360 degrees. So we're going to add a full circle. And feel free to use your calculator for these. Negative 100 degrees plus 360 degrees equals 260 degrees. So these angles are coterminal, and let's take a look at what it will look like on the coordinate plane. So this is a 260 degree angle, and we end up right here. And then what does it mean to go negative? It means to go in a clockwise direction. So we're moving 100 degrees, but in a clockwise direction, and notice how we end up on the same terminal side. So we know that 260 degrees is a coterminal angle of negative 100 degrees. Let's look at another example with a negative angle. So here we're going to find a coterminal angle of negative 30 degrees. This is less than 0 degrees. So what we're going to do is add a full circle. So we start off with negative 30 degrees and then add 360 degrees. And this would equal 330 degrees. So we know that 330 degrees is a coterminal angle of negative 30 degrees. And I'm drawing it out here. We end up right here on this terminal side. And negative 30 degrees is going 30 degrees, but in a clockwise direction. Notice how we end up on the same terminal side. So these two angles are coterminal. And then let's look at one more example for today. So we're going to find a coterminal angle theta of negative 480 degrees. So we know that this is a lot smaller than 0 degrees. So what we're going to do is add a full circle. So we start off with negative 480 degrees and add 360 degrees. We end up with negative 120 degrees, which is still smaller than 0. So since it's less than 0 degrees, we're going to add another full circle, so another 360 degrees, and we get 240 degrees. So 240 degrees is a coterminal angle of negative 480 degrees. And so what does this look like on a coordinate plane? Here's the terminal side of 240 degrees. And notice how even if we go negative 480 degrees, so remember in that clockwise direction, we end up on the same terminal side. And since we end up on the same terminal side, these are coterminal angles. And that negative 120 degrees we found in the middle would also be a coterminal angle. So here's a quick review for today's lesson. Two angles are coterminal if they end up in the same spot. So if they end up on the same terminal side, then the angles are coterminal. And to find coterminal angles, basically just keep adding or subtracting full circles. So keep adding or subtracting 360 degrees, and that will be your coterminal angle. And that's the end for today's lesson. Awesome job, and please remember to submit your notes on Canvas.